Hey guys, this is Terrence. Welcome to an architect's processing notebook. The topic of this video is this Japanese wave pattern. As you guys can find a lot of similar pattern or a lot of identical pattern on the internet, I prefer to add some detail to our works to make it unique from other similar ones. I added an overall gradient from top to bottom, and I also add gradients on each of the wave units. And also I placed this circle here to represent the sun, and I want the sun blend into our background. So let's get started. Let me first bring up the process of creating this pattern. The first step is we need to lay out circles. We need to figure out how many circles we want to place along the x-axis and how many circles we want to place along the y-axis. We also need to figure out the spacing of each circle. We need to figure out x spacing, y spacing, and also we need radius of each circle. After we have the circle layout, we need to find a way to transit or to transform. We need to find a transition that we move each of the circle to overlap them with each other, then create the skeleton or the foundation of our wave pattern. And I figure out that the move along the x-axis equals to half radius, and the move along the y-axis actually equals to 3/4 of radius. That makes the distance between these circle a quarter radius. Yeah. And after we have this, we can start to draw multiple circles inside each of the units. We should figure out how many circles we want to create inside each circle and figure out each of the internal circles radius. Then we can start painting these circles. The color mode we want to use is HSB, is hue, saturation, brightness. It's hue, saturation, brightness. And we have two levels of gradient here. In the overall level, we expect an increase in hue and saturation while a decrease in brightness from top to bottom. But when we dive into each of the wave units, we expect a reverse one. We expect a decrease in hue and saturation and an increase in brightness from outward to inwards. After we have all the wave pattern, we can start overlaying a circle to our pattern. We don't want to just draw a circle, a very destructive circle there, and adjust the opacity. That's totally how to say that doesn't work. That can't create an attractive image. So I will use a processing blend mode function to find a way to blend the circle into our background, I think. So we can start working this out by our code. So first, let me open up the processing. I will create a new file here. Processing and new file. Let me drag this here and save this file to our desktop. I will call it the wave. Yes. And then I prefer to put this aside to figure out each of our steps. So first we need to set up our canvas. We can say void setup. And I prefer to make our size as 800 by 800. And we create a draw function here. Keep this function empty for now. And I think we should figure out the number of circle along each axis. So I want to say integer. I want to do this outside the two functions. I want to make this a global variable. So I want to say integer x number equals to maybe let's keep it 5 for now. And the integer for y number equals to 5 as well. And we can, inside here, we can start to loop over these two numbers. We can say for j in, sorry, for intj in, not in, for intj equals to 0 when j is smaller than y number j plus plus. And inside here, I will create another for loop. We will loop over x number this time. We can say inti equals to 0, I smaller than x number, and I plus plus. Yes. Do we have another curly bracket? Yes, we have. And we have these two for loops. We can start placing circles. But before this, maybe we need to calculate the x spacing, y spacing, and the radius as well. So I think we can do this here. We can say float. We want a float value. Float x step equals to width divided by a float x number. And we do the same thing on the y step, equals to height divided by a float number, a float y number. Okay, we have these two steps, and we also need a radius. I think I can make the radius float radius. I can make the radius, radius equals to x step. So the circles will attach along the x-axis. And inside here, I think we can start drawing circles. Maybe we can say ellipse, sorry, ellipse, E-L-L-I-P. A little confused, PSE, SE. And with the x coordinates, I want to make them separate. I can say float x position equals to I multiplied by x step, and float y position equals to j multiplied by xy step. Yes, y step here, and we can place these two values here inside this ellipse function. We can say ellipse x position, y position, radius, and radius. And let's see the result. Let me move this here. Now we have our result, but we find there is a little shift to the upper left corner. Why don't we move these circles back into the center of our, move these circles back, that the circles fit our windows or our canvas. So I want to do this here. I want to translate half distance, half x step down and half y step right. I can say x step divided by 2 and y step divided by 2 as well, and save it, run the code. Yes, now we have this. The next step is to move these circles, to move them to the correct position. Then they will have then we can construct a skeleton of our wavy shape. So let's first figure out the transition along the x-axis. I think here we can say what? Here we can say I want to reframe this ellipse part here. I want to use the push matrix and pop matrix method to move the matrix instead of place the ellipse according to xy position. And here I can say translate to X position, Y position. And we have this translate, we just need to replace these two values to 0, save the code, and we get exact the same result. Then we will need some computations on these two lines of code to move these circles. I think on the x-axis we can decide we can try to decide which line of circles we need to move. Those circles need to move has the y-index of like 1, 3, 5, or 7. They are odd numbers. So we can say just after this line of code, we can say plus j modulo by 2 and multiply by x step divided by 2, I think. Save the code and run it. Yes, we have this x transition. Now we need y transition. On the y transition, it's much simpler. We just need to divide this by 4. Divide this y step by 4, I think. So I can do this y step on y step. Yes, we have this, but you can say now we don't have enough circles to fill the whole pattern. So we need to add the number along the y-axis. As we are dividing the y step by 4, so I think the number along the y-axis should multiply by 4 compared to its origin number. So I can directly multiply, sorry, not this number, it is this number. I can multiply y number by 4, then we will get this pattern. And as you guys can see, we have some weird parts on the top here and on the left side here. We want this part also have the wave fillings. So maybe we need to modify these two parts. We should say j start from -1 and I start from -1 as well. Save the code and run it. Yes, we have this, but you guys can see here is still a weird corner here. That's because the first step is -1. So when this value equals to -1, this will cause a very weird transition result. So we need to wrap this we need to wrap this j value with an absolute function. We want to any of the j value should be 0 or a positive number. So we do absolute, not abstract. Abstract is abstract. Yeah. So absolute function here make this value positive or 0. Let's save it and run it again. I think we have our base shape. We have our foundations here. Then the next step is to draw multiple circles inside each of the circles. I mean, we need to draw multiple internal circles. So in this condition, we need to figure out the number of circles we want inside here. And we can declare this value here. I can say integer, it should be integer number, integer, I can call circle number equals to 4. And we also need to figure out each of the internal circles radius. So here I want to calculate the sub-radius. I can say float sub-radius equals to x step divided by circle number, and I prefer to first print this number out to check the data type of this sub-radius. And at the bottom here, I prefer to place a no loop. Because we are creating a static image, we don't want the same image loop again and again and again. That's a huge waste of our computer's computing power. Let me run it, and I can see it's 40.0. It's a float number. Is it correct? Or if I place a float here, save the code and run it, I think, yeah, we get the exact same result. Okay, just leave this part here. So inside this function, now we need to add another loop to loop over the circle number. Then we draw circle again and again and again. But please be noticed that because the circle are overlapped, we can't draw the large circle over the small circle, or the small circle will disappear. So the sequence is we draw large circle, then overlap it with smaller circle, then smaller circle again. So when looping over this number, we should start from the end, start from 4, then decrease the number one by one. So here I want to say for integer k equals to circle number, and when k is larger or equal than 1, we run the code, or k minus 1. Because I don't want the circle with 0 radius, that's totally make no sense, so I place here, so this part of code could be k is larger or equal than 1. I don't want to make it k larger or equal than 0. That will cause a non-radius circle. That's kind of error here. So let's keep doing something inside here. I can say, I can copy and paste this line of code inside here. I want to make a correct indentation. And inside here, we need to figure out the radius. I can say float r. We just use a single r here for the concise, for the simplicity of our code. R equals to, do I have the, yeah, I think it's more proper to call this r step instead of circle radius. I remove this print line, r step, and I can say r equals to r step multiplied by k, then replace these two values with r. Save the code and run it. Yes, and I think we have the very basic of our pattern. We just haven't shaded, and it is already a Japanese wavy pattern. The next step is we can render this pattern, make it looks better. So we should first define the color mode. Up here, we can say the color mode is HSB, hue, saturation, brightness, and set their maximum values, 360, 100, and 100 as well. And we need a background, right? Sorry, background is 360. Then we need to define, we can try to define each of the hue, saturation, brightness value as a, as a base, as a basic, as an overall value, I think, or universal value. So I think here we can say float, no, we can use integer. That might be better. Integer hue equals to 180. This is my preference. You can use the color you like. And int saturation equals to 15. Integer saturation, and integer brightness equals to 90. I think yes. Then we can start apply this hue, saturation, brightness to our ellipse. So we can first make our stroke white. Okay, we can say stroke. So stroke color could be 350. I don't want it I don't want it completely bright. I want it have some grayscale, so I use 350, and I will define a stroke weight, which is the thickness of the stroke. I will define it as 5.5, and also I will define the fill value, the color of the circles. I can say fill value equals to hue, saturation, and brightness. Then we save the code, run it, and I think we get this pattern. The next step is to create a gradient, create an overall gradient on this pattern. We want the top part be lighter, the bottom part be darker. So what we should do is after each of the for loop on the x number, after this part, we modify, sorry, let's move this part here. We modify the hue, saturation, brightness value on each line of circles. So we can modify this number after each of the loop over the x-axis, I think. Well, this is a little bit confused, but when you start doing it, it's no longer confused at all. So I can just make some modification here. I can say, after looking over each line of circle, we increase the hue value by 2. We increase the saturation value by 2, maybe. And also we need to decrease the brightness value here. Saturation, why I make the same mistake again and again? Brightness should be decreased by 2, and save the code, run it, and you can see we have our gradient. And the next step is we already have the overall gradient. We also want a reversed gradient in each of the unit. So we can start doing this. I think we can do this inside here, somewhere here before painting these circles. And what I want to use is to create an offset value on the hue. So I can say integer hue offset value equals to hue plus k minus integer circle number. Sorry, it's not circle number. What I just defined? Yeah, it is circle number. Circle number divided by 2. And this value. Okay, so first let me save this code. I want to explain this a little bit. That means each of the circle has its hue value. So we want to use the hue value as a middle value. We want the hue value on this outside circle a little darker than the standard value, and we want the hue value on the center internal circle a little lighter than the standard value. So I use k minus the circle number divided by 2. So each time hue will plus the standard hue value will plus the offset value. Then I can save this code and run it. You can still figure out the gradient, but it's not that distinguishable. So I will increase this offset part here. I want multiply it by 6. Save the code and run it. Yes, now you can see both gradients are noticeable. And I think the final step is we want to add a circle. We want to add a circle here. We want to use the blend mode to add a circle. So I want to do this after both loops. So first, let's save the code we did so far. And after all this, before the no loop, we add a circle. We can say we should first define a blend mode here. That means we are defining how this circle blend into background. The mode I want to use is called screen. And then I want to draw a circle. First, I don't want the stroke here. And I want to fill it with some kind of red value. The red value locates, sorry, it's no stroke here. The red value locates on the angle of maybe around 10 on the hue wheel, on the hue saturation brightness wheel, and set both brightness and saturation as 100. Then I will draw an ellipse, IPSE, which one? SE. Okay, so I can say maybe the center could be width divided by 2, height GHT divided by 2 as well, and the radius could be 400. Oh, it's not radius, it's twice radius. Save code and run it. Yeah, we can see, yeah, the circle is here, and the wave color inside the circle has a very high contrast to the rest part of the wave. The next step is we want to add a little interactivity to here. We want the circle following our mouse movement. So in this condition, we might need another function down here. We can say void mouse moved past tense. And if we want to, sorry, let me run the code again. If we want the center of circle move with our mouse, we need a global variable that can control the center of the circle. So in this condition, we need to define a global value which represents the circle's center x and center y. So I can say float circle center x equals to, maybe I want to put it aside, maybe sorry, I prefer to declare to empty value here because I want the width and height value control. I want both of width and height value control these two center values. So I want to say here circle center x equals to width divided by 2 and maybe plus 50, and circle center y equals height divided by 2. Then we apply these two values to our circle center, but center. Okay, save the code, and we apply this true value to this ellipse function. This should be circle center x, and this should be circle center y. Save the code and run it. Yes, we still have this here. Then we can start adding interactivity here. In this function, when our mouse moved, we want the center x equals to the mouse x. We also want the center y equals to the mouse y value. So we can say center x, circle circle center x. Well, it's so hard in speaking English, sorry. Circle center x equals to mouse x, yeah, and circle center y equals to mouse y value, and save the code, run it. You can't see any interactivity because we put no loop here. If we remove this no loop, we can have this, oh no, I know what's going on here because we set the blend mode screen. We didn't, this screen blend mode will keep applying to the next loop of the draw function that will make the whole image disappear. So here I should still set the blend mode to the default value, which is blend. I think this works. Yes, you can see we have this interactivity, but the reason I put no loop here is to save our computer's computing power, save our CPU resource. And I still want to do so because I don't want the same value repeats again and again and again. So I still keep this no loop here. But in order to update the pattern when I move the mouse, I will do another function called redraw, D-R-A-W, redraw here, save the code. And in this condition, we can have interactivity while we don't waste the computer's resource or computing power. And this is the pattern we want. And this is all we have for today. And I think, yes, we already finished this pattern. Okay, thank you guys for watching this video. If you guys have any questions, comments, or critics, please leave them in the comments. I will reply. I will reply every single of your comments or concerns. And also from today on, I will put this, I will put all of my sketches to the OpenProcessing. That's an awesome website. Instead of put them on the GitHub, because on GitHub you can just see the code, but on OpenProcessing you can see the pattern, you can see the sketch, and you can also interact with this sketch. That's a much better method of uploading my code, I think. And you guys can find my OpenProcessing link of this sketch just in the introduction of this video. So that's it. Thank you so much. Bye bye.